Dear physics aspirants, right now here is Geiger-Marsden scattering experiment. The entire apparatus is placed in a vacuum chamber, not shown in the figure. So gold foil is here and screen is here, and source of alpha particles you will see the vacuum, and here you will see the alpha particles emitted by the radioactive source where Bi were collimated into a narrow beam by their passage through lead bricks. The beam was allowed to fall on a thin foil of gold thickness 2.1 into 10 to the power minus 7 meter. Here you will see the schematic arrangement of the Geiger-Marsden experiment. Zinc sulfate screen, large angle scattering of some backward scattering of a very small fraction 1 to 8000 or so, source of alpha particle lead bricks, beam of alpha particle the gold foil, and a small angle scattering of some zinc sulfate detector microscope you will see here. Alpha particle is scattering and Rutherford's nuclear model of atom has been given here, and at the suggestion of Ernst Rutherford in 1911, H. Geiger and E. Marsden performed some experiments. In one of their experiments, as shown figure 12.1, here is 12.1 and 12.2. They directed a beam of a 5.5 MeV alpha particles, electron volt, emitted from a 283 to 14 Bi radioactive source at a thin metal foil made of gold. Figure 12.2 solves a schematic diagram of this experiment. Alpha particles emitted by 83 to 14 Bi radioactive source were collimated into a narrow beam by their passage through lead bricks. You will see here the beam was allowed to fall on a thin foil of gold of thickness 2.1 into 10 to the power minus 7 meter. The scattered alpha particles were observed through a rotatable detector consisting of zinc sulfide screen and a microscope. You will see here and detector consisting of zinc sulfide screen and a microscope. The scattered alpha particles on striking on a screen produced brief light flashes or scintillations. Dazzling. These flashes may be viewed through a microscope, and the distribution of the number of scattered particles may be studied as a function of angle of scattering. Angle will be theta, and this can be shown with the help of microscope. Naked eye cannot see these things in vacuum. So when you study and you will arrange the experimental methods and experimental thought, and apparatus has been set up, and microscope will be very important for viewing the source and the activity. A typical graph of the total number of alpha particles scattered in different angles in a given interval of times is shown in figure 12.3. 12.3, when you study the experimental data points shown by dots on scattering of alpha particles by thin foil at different angles obtained by Geiger and Marsden using the setup shown in figures 2 and 12.1. and 12.2. Rutherford's nuclear model predicts the solid curve, which is seen to be in good agreement with experiment. The chapter will come under atoms. of the NCERT book physics +2 level. Here you will see the particle scattered in different angles in given interval of time is shown in figure 12.3. The dots in this figure represent the data points and the solid curves is the theoretical prediction based on the assumption that the target atom has a small dense positively charged nucleus. Many of the alpha particles pass through the foil. It means that they do not suffer any collisions. Only about 0 to 14% of the incident alpha particles is scattered by more than 1 degree and about 1 in 8000 deflect by more than 90 degree. Rutherford argued that to deflect the alpha particle backward it must experience a large repulsive force. So the large repulsive force will be very important. This force could be provided if the greater part of the mass of the atom and its positive charge were concentrated tightly at its center. Then the incoming alpha particle could get very close to the positive charge without penetrating it, and such a close encounter would result in a large deflection. This agreement supported the hypothesis of the nuclear atom. This is why Rutherford is credited with the discovery of the nucleus. Uh, the leftover is here in Rutherford's nuclear model of the atom. The entire positive charge and most of the mass of the atom are concentrated in the nucleus with the electrons some distance away. And here is the matter. We will discuss these matters in the next video. The other page is here. The magnitude of this force is the F is equal to 4 pi E0 is into 2 E Z by R square. And after that we will discuss the alpha particle trajectory of alpha particle in the column field is target nucleus. The impact parameter B and scattering angle theta are also depicted. So we will meet in the leftovers with the from here to here in the next video. Till then, thanks for watching the video. Thank you very much.